Hey YouTube, welcome to my next episode. So we're moving on from straight lines and we're going to apply all of our knowledge to equations of circles. So let's get right into it. So what is the general equation of a circle of radius r and center 0, 0? So if we take a circle with center 0, 0, we know that the whole point of a circle is that anywhere you are on the circumference, the distance to the center is fixed at r. So what we can do is we can draw a line to the circumference, call it r. Now we have a general point, xy. I just drew that line randomly, right? It could have been anywhere on the circumference. Now, this point is a distance x on the x-axis and y on the y-axis. We form a right-angled triangle, and then what links all of these three lengths together is Pythagoras' theorem. And then this derives the result straight away. So it's x squared plus y squared is r squared. So for a circle with center 0, 0, the general equation is x squared plus y squared is r squared, where r is the radius. Now what happens when we change the center from 0, 0 to AB? Now it's actually quite simple. So all that's happening is there is a transformation, and it's a translation in this case. So we're taking the original circle that's at 0, 0, we're shifting it to the right by A, and we're then shifting it up by B. So for example, if we had f of x, and we shift to the right by a, it becomes f of x minus a. So wherever you see x in the original equation, it changes to x minus a, and then squared. And the same goes for y. We are translating it up by b. So if it was f of y, a function of y, which this is a function of y, if we are shifting it up by b, it becomes f of y minus b. So instead of y, we change it to y minus b squared, and then the radius we said is still r. So for a circle with the center being AB, that's your equation, and it's actually still the same as the other. So if you let a and b equal 0, you just get the original equation. So really, you should only remember one because the other is just a special case of the x minus a formula. So write down an equation of the circle with the given center and radius in each case. So if we have center 0, 0, it's going to be x squared plus y squared, and then the radius is 3, so we're going to square that to give us 9. Then a center minus 6, 10, we're going to get x. Now remember, it's x minus a. The x coordinate is a, so if the x coordinate is minus 6, it becomes x minus minus 6, which becomes x plus 6 squared plus y minus 10 squared equals 4 root 2 squared. Now, when we square that, we square 4, which is 16. When we square root 2, we get 2, so it's 16 times 2, which is 32. Hey guys, I hope you enjoyed my video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button. Comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. Write down the coordinates of the center and radius of each of the following circles. So for the first one, we can see it's just an x squared plus y squared, so it'll be 0, 0. Mate, this fucking WhatsApp, man. I swear I turned it off. Mate. Next question, write down the coordinates of the center and radius of each of the following circles. So the first part, x squared plus y squared is 81. So here it's just the standard center being 0, 0. So the center is 0, 0. And the radius is the root of 81, which is 9. For part B, remember it's x minus a. So for it to be a plus 2, the center is going to be minus 2. Then y minus 3 means that b is 3 in this case. And the radius is root 144, so 12. A circle C has center 3, 4 and passes through the point 8, minus 8. Find an equation for C. So with all these questions, I always recommend we do a sketch. So the center is 3, 4. And it goes through 8 minus 8. Just say somewhere here. Now don't diss my circle, but it's going to look something like this. It's not that bad, right? So what we need is the radius. So the radius is going to be the distance between these 2 points. And in the last episode, the last episode, I showed you how to work out the distance between 2 points. We take away the coordinates. This works out the lengths of the triangle. And it doesn't matter which one you put on top, but 3 minus 8 is minus 5. 4 minus minus 8 will become 12. So we're just going to do Pythagoras. So the radius in this case, we don't need to worry about the minus because you're just squaring it, right? So 5 squared plus 12 squared rooted, it's just the 5, 12, 13 triangle. So the equation of C then will be x minus the x coordinate is 3 squared plus y minus the y coordinate 4 squared equals the radius squared. Now you can write 13 squared, but you might as well just work it out. So 169 in this case. Find an equation of the circle in which AB is a diameter now, with A being 3, 8, and B is 9 minus 6. So just a little sketch. We have A, which is 3, 8, and B is 9 minus 6. So it'd be somewhere down here. So if that's the diameter, we'd have some kind of circle like this. This is going straight through the middle. We know that the center of the circle is right in the middle. So we need to find the midpoint. So how do we work out midpoints? We add the coordinates and we divide by 2. So remember, it's finding the average, right? So 3 plus 9 is 12. 8 minus 6 is 2. Then we divide them by 2. So our center is 6, 1. And now we just need to find the radius. All we do is we just find the distance between the midpoint and any of the other coordinates on the circumference. Or you could find the distance between A and B, but then you have to half it after. So I'm just going to stick with doing one of the coordinates on the circumference and the center. So we take them away. 3 minus 6 is minus 3. 8 minus 1 is 7. So our radius is going to be 3 squared plus 7 squared rooted, which is just 49 plus 9. 49 plus 9 is 58. Now the reason I'm doing that is because we're going to end up squaring it, right? So essentially we're just getting rid of the square root. Yeah, so that's why I've just left it as 49 plus 9. So what is our equation of our circle? Well, the center is 6, 1, so it's x minus 6 squared plus y minus 1 squared equals root 58 squared, which is just 58. Now there's other ways we can represent the equation of the circle, and it's really simple. It just means in our brackets, the brackets are just expanded. So if we're ever given a circle in that form, then we need to observe a process or figure out a process that allows us to see what the center would be and what the radius would be. And it's very simple. It's what process do we do when we have quadratics, because we have x squareds and x's and stuff, which allows us to rewrite them with brackets and a squared on top. Well, the simple answer you probably know is completing the square. So for these questions, find the coordinates of the center and radius of each of the following circles. So here's our equation. It's just the expanded form of the circle. What you do very simply is just write the x's together and the y's together. The 9 you can move on the other side if you want, but I'm just going to keep it here. Now, if you want to revise your completing the square, look at one of my earlier episodes where I walked you through exactly how to do them. So you're going to have x plus half the coefficient of x is 3 squared. Subtract this number squared, well 3 squared is 9, plus y minus half the coefficient is 6 squared. Subtract this number squared is 36, and then plus 9 is 0. Which is nice because the 9's cancel and the minus 36 can go to the other side. So you have x plus 3 squared, y minus 6 squared is 36. So our center here is the negative, so minus 3, and the negative of this is 6. And the radius is just root 36, which is 6. Now for part B, It's actually an interesting example. So what a lot of students do is they factorize out 3. The easiest way to do this is because it equals 0, just divide through by 3. Yeah, if when it comes to circles, the coefficients of x squared and y squared always have to be the same. Yeah, they'll never give you an example where that's not the case. Yeah, so otherwise it's not a circle anymore. So we're going to divide through by 3 first. And what I'm going to do is show this 9x. I'm just going to write it next to the x squared term as well. So dividing through by 3, we have x squared. 9x divided by 3 is 3x. Then we have y squared minus 15 divided by 3 is 5y. Then be careful, this we have to divide by 3 as well. So we have 2/3 is 0. Then we apply our process. So it's x plus half the coefficient of x would be 3/2 squared. Subtract this number squared. Well, we square the top and we square the bottom. Plus y minus half the coefficient of y would be 5/2 squared minus square this number would be 25/4 plus 2/3 equals 0. So we're left with x plus 3/2 squared plus y minus 5/2 squared, and then we're going to move everything to the other side, right? So here we can get our calculator out. So we are doing, moving everything to the other side, it will become positive 9/4. Then we will have positive 25/4. And then it will be minus 2/3, right? Minus 2/3. So we've got 47/6. So 47/6. So the center here is minus 3/2, 5/2. And the radius, all we need to do is root this. So we're going to root answer. And there is our answer. So root 282/6. So this is just a task of completing the square, really. Last question. The point P lies on the circle with the equation x squared plus y squared plus 10x minus 4y plus 25 is 0. And the point Q has coordinates 1, 1. Find the minimum length of PQ. Right. All words, and it's to do with circles. So we're going to complete the square, which allows us to figure out the center of the circle and the radius, and then we can do a sketch. So we're going to have x plus half the coefficient of x is 5 squared. Subtract this number squared is 25 plus bracket y. Half the coefficient of y is minus 2 squared. Subtract this number squared is 4 plus 25 is 0. The 25's cancel. We have x plus 5 squared plus y minus 2 squared equals 4. So when we come to sketch our circle, the center is minus 5, 2. So say here, minus 5, 2. And the radius is 2. Now you want to be careful how you sketch this. Because the radius is 2, it's actually going to come down and touch the x-axis. It's going to look something like this. Yeah. Now it says P is anywhere on the circle. It's essentially saying, where does P have to be? So that it's distance from Q, and Q is at 1, 1, somewhere here. So that the length between P and Q is at its shortest. So you have to wonder, could it be here, 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 here? Eventually you come to realize that it has to be somewhere around here. Now what's special about this point P? What's special is that if you were to draw a line straight through P, it would have to go to the center. Now the reason for that is because if they ask for the longest distance, then you would have to trace the whole diameter, and the diameter has to go through the center. So for the shortest distance, you also have to trace that line that would have been the diameter. So it has to go through the center. So they're asking for this length D. So how do we do that? Well, nice and simply, we work out the distance between Q and the center, And then the only thing we need to subtract is the radius. So let's do that. So we're going to do 1, 1 minus minus 5, 2. 1 minus minus 5 is 6. 1 minus 2 is minus 1. So that long distance is, let's call it x. X is root 6 squared plus 1 squared, which is just root 37. Then what's the radius? Well, the radius we know is 2. Therefore, D, which is the shortest distance between P and Q, is just root 37 minus 2, and you can leave your answer like that. So here's a summary of equations of circles, and we've applied it to different situations and done an exam question as well. Stay tuned for the next episode where we're going to look at perpendicular bisectors as well. So guys, if you enjoyed today's episode, if you've learned anything, please hit the like button. If you want more maths content, then make sure you're subscribed, and I'll see you guys in the next episode. Peace.